Have you ever really stopped to think about how, well, this is reaching you right now? It feels instant, but it's actually traveling as tiny pulses of light, zipping through these little glass tubes across whole continents and deep under oceans, all at pretty much the speed of light. It's kind of mind-blowing. Okay, so let's dive into how this incredible technology actually works.
I mean, it seems impossible, right? How on earth can you trap light, which we all know loves to travel in a straight line, inside a tiny, flexible glass thread that's literally thousands of kilometers long? That is the big question, and that's exactly what we're going to unravel today.
And I'm not exaggerating here. The entire backbone of our digital world, the very thing carrying my voice to you right this second, is built on these impossibly thin, incredibly long strands of pure glass. So, to understand the trick, we've got to look at the anatomy of the fiber itself. Let's zoom in and see what these things are actually made of. Now, what's really cool is the structure here. A single one of these big fiber optic cables actually contains hundreds of individual fibers. And as you can see, they even come in different flavors, like single mode or multi-mode for different jobs. But they all share this very precise, layered design. So it all boils down to these two parts. You've got the core. That's the super pure glass highway for the light signal. But the secret weapon, the real magic, is the cladding. It's this second layer of glass wrapped around the core, and its only job is to be the perfect, inescapable cage for that light. But how does the cladding do it? It's not like a physical wall in the way we'd normally think. Nope, it all comes down to a really beautiful principle of physics. This is the absolute best way to picture it. If you've ever been underwater in a swimming pool and you look up at the surface from a really shallow angle, you don't see the sky, do you? You see this perfect silvery reflection of the bottom of the pool. That exact same thing is what's happening inside the fiber. And there's a fancy name for it: total internal reflection. Instead of the light escaping when it hits the boundary between the two types of glass, it is completely 100% reflected back inside. Zero light gets out. So here's the recipe to make it all work. You need three things. First, the glass in that inner core has to be optically denser than the outer cladding. Just think of it like how light moves slower in water than it does in air. Second, the light has to hit that boundary at a super shallow angle. And third, if that angle is shallow enough, past a certain point they call the critical angle, the light physically cannot escape. It's forced to reflect. You get a perfect bounce every single time. It's really like the light is traveling down a flawless tunnel of mirrors. That little pulse of light just ricochets off the walls, bouncing its way down the fiber for miles and miles, even when the cable itself is bending and curving around corners. And because that reflection is total, almost none of the signal's energy is lost along the way. This incredible efficiency is what lets us send data across entire oceans. Okay, so we've got the light trapped. Awesome. Now, how do we use it to send, say, an email or stream a 4K movie? Well, that's the next part of the puzzle, turning these bounces of light into a language machines can understand. And the system is just brilliantly simple. It's binary code. You have a laser at one end that's just flashing on and off at an incredible speed. A pulse of light, that's a 1. No light, that's a 0. And we're talking billions of these ones and zeros being strung together every single second. Those sequences of light and dark are then picked up by a receiver on the other end, decoded, and turned back into, well, everything we do online. Okay, so even with this amazing total internal reflection, no system is totally perfect. Over huge distances, like these 6,600 kilometers between Spain and the US, that light signal does eventually start to fade just a little bit. The solution for this is so clever. Along the length of these undersea cables, they place these devices called repeaters, or optical amplifiers. They basically catch the faint light signal, give it a power boost back to its original strength, and then send it on its merry way. This just makes sure the message arrives crystal clear. So let's zoom all the way out. We've got the fiber, we've got the physics, and we've got the data. What does this actually look like on a global scale? Well, the answer is, it's pretty much everything. Just look at this number, 99%. That's how much of all international internet traffic travels through this massive hidden network of undersea fiber optic cables. It's not satellites, it's this. This is the true circulatory system of our digital age. And here is why this was such a complete game changer. Just look at the comparison to the old copper cables. The bandwidth? We jumped from megabits to terabits per second. Distance? Fiber can go over 100 kilometers without a boost.
Copper fades in less than one. I mean, it is just a completely different league of technology. And to put that bandwidth into perspective, a modern cable, like the Maria cable that connects the US and Spain, it can handle 200 terabits per second. That's like streaming tens of millions of HD movies, all at the same time. A capacity like this isn't just about faster downloads now. It's what makes the future of things like the metaverse, global AI, and real-time cloud computing even possible.
So yeah, the next time you stream a 4K movie and it doesn't buffer, or you play an online game with someone on the other side of the planet with zero lag, this is the technology you can think. It literally powers our entire connected world.
When you really think about it, what this technology did was a kind of modern-day alchemy. It took one of the most fundamental things in the universe, light, and transformed it into the language of information. And in doing so, it created the invisible, essential backbone of our entire world. It's this giant network hidden away under our oceans and beneath our streets, a constant river of light that we never, ever see, but that we absolutely could not live without.